Hi everyone, let's solve the problem best time to buy and sell stock. You are given an array prices where prices of I is the price of a given stock on ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So this is the problem statement. What they're trying to say is that if you're buying a stock on ith day, you can only sell it on I plus 1th day or few in the future, but you cannot sell it on the same ith day. That is all they are trying to say. And maximum profit is what you have to return. And if there is no profit, you just have to return the 0. So in that case, let profit equal to 0 and we will return profit. That is all we are going to do. Now let's understand the problem statement with the example. Let's consider this as an array, prices. Now if this is my buying price, any one of them can be my selling prices, and whichever is the maximum selling price minus my current buying price will give me the maximum profit. That is how it works, right? So the algorithm is that you kind of fix the buy price and find the maximum of the remaining elements and then subtract and update your profit. So in this case, let's say initially profit is 0. Now my buy price is 7. Now let's consider my sell price. Sell price is 1 minus 7 is what? Minus 6. So I don't have to update my profit. 5 minus 7 is minus 2. I don't have to update my value, so on. Like I will iterate over all the elements in the future and I will subtract the 7 value buying price and calculate the profit. Now let's consider my buy price is 1 and my sell price can only be 5364, right, in the future. 5 minus 1 is 4, so I just have to update the profit. 3 minus 1 is 2, so I don't have to update the profit because it's already maximum. 6 minus 1 is 5, so the profit I got is more than the previous one, so I'll update. 4 minus 1 is 3, again profit is already more, so we don't have to update. So basically you will fix the buy price and you will iterate over all the selling prices and check the max profit. So let's code it up. Let I equal to 0, I less than prices dot length I plus plus const buy price is what I am fixing currently. Then what will I do is that for every, okay, now I will iterate over all the future or the selling prices and length and j plus plus. Okay, this is j less than prices dot length and j plus plus const sell price is nothing but prices of j. Now my profit will be updated in such that math dot max of profit comma sell price minus buy price, and I'll be able to return the answer. This is all we are trying to do. It's a simple solution. Now let's try to run this code. Okay, let me try to submit it. It will fail because the time complexity of this solution is n square and the constraints which are given 10 power 5 does not fit into the limits which it can run. So it is going to give us a time limit exceeded. Let's try to submit. Right, we got the time limit exceeded. Now let's discuss a better solution. Instead of me fixing the buy price, can I fix the sell price? I can fix the sell price. Let's say sell price is 1. Now my buy price will be minimum value from 0 to 0 for this particular case, right? 0 to 0, that is nothing but 7, and then 1 minus 7 is minus 6, so we don't update our value. Now I will consider 5 as my selling price. So the minimum values, minimum between 7 comma 1, or basically I'm trying to write, instead of writing index, I'm writing the value 7 comma 1 will be what? 1. 5 minus 1 is nothing but 4, so I'll update my profit, and so on. But now the question is, instead of finding the minimum again and again, we are any which ways iterating over the array. Can I not minimum buy price is what I will maintain? When I am at 1, I will already assign my minimum buy price as 7. So 1 minus 7 is what? Okay, let me restart the conversation so that it is clear. So instead of iterating and finding the minimum, I'm trying to optimize and find the minimum while we are iterating through the array. That's the trick here. Profit is the profit we have here is 0 initially, and I am trying to fix the selling price instead of buy price, which we did in the previous solution. Sell price is 1 here. Now once I have the sell price, I will first have the minimum buy price. When I'm starting selling price at here, obviously this will be my minimum buy price, the 0th index 7. Now 1 minus 7 is what? Minus 6, so I don't have to update my previous. Now once I am moving from 1 to 5, before moving 1 to 5, can I do minimum of min buy price comma 1, which is my current element. If I do that, I will again get an answer. Min buy price is now 1, right? Now the minimum buy price is 1. The sell price I can move to 5. Now 5 is my selling price and my minimum buying price is 1. 5 minus 1 is 4. So I will update my value. Now again I will move to the next element, selling price, and before moving to this selling price, I will also again calculate minimum of 1 comma 5, which was my last element, and the minimum is 1, right? So on. Basically I will, instead of calculating the minimum every time for every selling price, I'm just utilizing the previous min so far, and I'm checking if the current value is minimum or not. Let's code this up, you will understand it better. So the solution, the profit part remains same. Minimum buy price is prices of 0. Initially we are kind of ensuring that we are assigning the first one because we are starting our values from the first element. So I will start it from this const current prices of I. Now when I am calculating profit, I will have to do again math.max of profit, which is there. Now with my current price is nothing but a sell price because I am fixating the sell price, minus, we already know what is minimum so far within that particular range, so I am subtracting. It will give me the profit. Now once this is done, before I move, I will also have to update my min buy price. So math dot min of min buy price, which is already existing one, versus the current price I have seen, or the current price of the day, and then we just keep iterating, right? Now let's try to run this code. it is running. Let's submit it. It's successful. So let's understand the time and space complexity of the solution. Time complexity is big O of n, because we are just iterating over all the elements 1, and all of these operations will take big O of 1, so we don't have to consider them. Space complexity is big O of 1. So the trick in this solution is that we are any which ways traversing, but while traversing we just have to find the minimum value within the same, like if I have already traversed, so here I know the minimum. When I'm traversing here, I know this value and I have seen the minimum so far. So 7 and 1 will be 1, and 5 and 1, and in this it will be 1. So it's just basically finding the minimum on the fly instead of like iterating and finding. Okay, thank you guys.